By all means, the example that you see is a very trivial case in the sense it is very easy to solve. If someone asks you, well, which one to eliminate, you should say X, because one is negative, the other is positive. As far as I am concerned, I would either subtract or add the two equations. Some people like to say, okay, always add or always subtract. It doesn't matter. So I like to add or subtract the two equations depending on the scenario. But the golden rule of thumb for me is to always multiply by a positive number. Anytime I use elimination, I would always multiply by positive numbers. In this problem, it is not needed. The next one, it will probably be needed. So here, X is easy to eliminate because one has a positive sign and the other negative. So I'm going to add the two equations. Negative X, positive X would go away. 2y plus 2y is 4y. And 0 plus 5 is 5. Divide by 4 on both sides. Y would be equal to 5 over 4. Once we have y equals 5 over 4, we could take that value and plug it in one of the two equations to solve for x. Once again, it is a matter of choice, depending on which one you find to be easier. To me, it's quite obvious. It's the first one, because the right-hand side is 0. Had I picked the second equation, I have a 5 here, then I have to add, subtract fractions, too much work. Since the right-hand side is 0, I'm going to pick the first equation. So minus x plus 2 times 5 over 4 equals 0. The 2 and the 4 will get cancelled. So minus x would be equal to minus 5 over 2. The negatives will get cancelled, and we will have x equals 5 over 2. So the solution is x is equal to 5 over 2 and y is equal to 5 over 4. Another good thing about elimination method is if you don't do any algebraic mistakes, you don't have to go back and check your answer by plugging it in. It's not necessary at all. So if you go through the process carefully without making any mistakes, you don't have to plug back in the values of x and y in one of the two equations, in both of the equations and verify the solution. Not needed. Here is another example. 6x minus y equals negative 5, and 4x minus 2y equals 6. So I have two equations, and I'm going to write this separately. What I'm going to do is I need to find a common factor to get rid of. You can either pick x or you can pick y. Just by looking at this system of equations, for me, y is easier. And as I mentioned, you can either subtract or add. There are some who prefer to add all the time, some who prefer to subtract all the time. For me, either would work. So I will always multiply by a positive number. So I'm going to multiply the first equation by 2. So I will get 12x minus 2y equals minus 10. The second equation, I'm going to keep it as is. 4x minus 2y equals 6. Going to subtract the two equations. So minus 2y minus of minus 2y will get cancelled. 12x minus 4x is 8x. Negative 10 minus 6 is negative 16. And we want to solve for x, so we divide by 8 on both sides. So x would be equal to negative 16 over 8. So x is negative 2. Once you have the value of x, you can plug it back in one of the two equations, entirely up to you. I'm going to go with the first one. Six times negative 2 minus y equals negative 5, which would mean negative 12 minus y would equal to negative 5. Negative y would be equal to negative 5 plus 12. Move the 12 from one side to the other. So negative y would be equal to positive 7. So if we want to solve for y would be negative 7. So the solution here is negative 2 for x and negative 7 for y. So we need to find a common factor between 3x and 2x. For me, that is going to be easier to solve. So I'm going to multiply the first equation by 2, multiply the second equation by 3. So 6x minus 10y equals 22. 4x minus 12y equals 4. Excuse me, I'm supposed to multiply by 3. 6x minus 18y equals 6. So here I'm subtracting. So if you multiplied the second equation by negative 3, instead of subtracting here, you will be adding. Again, that is entirely a matter of preference. If you want to do it this way, that's okay. If you want to multiply by negative 3 and add, that is also okay. You can choose the easier approach. 6x minus 6x will get cancelled. Minus 10y minus of minus 18y would be equal to 22 minus 6. So minus 10y plus 18y would be 8 times y. And that would be equal to 16. Divide by 8 on both sides, y would equal to 16 over 8, which is 2. Now I take that 2 and plug it in one of the two equations. In this problem, it doesn't matter. Both of them kind of look equally complicated. So I'll go with the second one. So 2x minus 6 times 2 equals 2. Two x minus 12 would equal 2. Which would mean 2x is 2 plus 12, which is 14. Divide by 2 on both sides. X is equal to 14 over 2. We get 7. So here we have a system of equations, but we have fractions. So anytime we have a fraction, it is good to get rid of the denominator so that we don't have to deal with the fraction. So And when we eliminate, it's always good to get rid of the bigger number. So what I'm going to do first is multiply both sides by 4. Oops. Multiply by 4. So 4 times 3 over 4x plus 4 times 5 over 2y would equal to 4 times 11. Second equation, again, I want to get rid of the bigger fraction or the bigger denominator. So multiply by 16 on both sides. 16 times 1 over 16x minus 16 times 3 over 4y equal to negative 1 times 16. So the first equation, the 4's will get cancelled, the 2 and the 4 will get cancelled. 16 would go away, 4 and 16 would get cancelled 4 times. So the first equation would now become 3x plus 2y equals 44. The second equation is x minus 12y equals negative 16. So what was complicated here became simple there. So always get rid of the fraction. Now, between x and y, it seems like getting rid of x is a better idea. I'm going to keep the first equation as is. Second equation, I'm going to multiply by 3. So 3x minus 36y, 12 times 3, would be equal to negative 48. Now I have to subtract the two equations. 3x and 3x would go away. 38 or 2y minus 36y would be equal to 44 minus 48. I'm subtracting the two equations. So 2y plus 36y is 38y. And on the other side, we have 92. Divide by 38 on both sides. We can simplify this further. There is a 2 in common, so we have 46 over 19. We can take that 46 over 19 and plug it in one of the two equations. It seems to me that in this problem, the second equation would be better. So plug in y equals 46 over 19 in the second equation. So x minus 12 times 46 over 19 would be equal to negative 16. So I made a mistake because the answer didn't go the way I wanted to. That shouldn't be a 2y, that should actually be 10y, because 2 times 5y is 10y, which would change pretty much everything. It only takes one mistake to ruin the entire problem. So 3x plus 10y equals 44. That's the first equation. going to keep that as is. The second equation, I'm going to multiply by 3. So 3x minus 36y equals minus 48. Now subtract the 2, 3x would go away. 10y minus of minus 36y would be equal to 44 minus of minus 48. So 46y would equal to 92. Y would be 92 over 46, which will be 2. Now, you may ask me, well, how did he spot that he made a mistake? Well, I got the answer. The answer seemed quite weird. As far as this class is concerned, the fractions are going to be quite simple. The x and y values are going to be simple. And I looked at the answer and it looked totally weird. So immediately I started questioning myself, okay, perhaps I made a mistake somewhere. So we spotted the mistake now. So y is equal to 2. I'm going to take that. And plug it in the second equation. So x minus 12 times 2 would be equal to negative 16. X minus 24 would be equal to negative 16. Add 24 to both sides, we would have negative 16 plus 24, which would mean x is 8. So in this problem, we're trying to eliminate the fraction before proceeding with elimination, but we are in a tough situation, regardless of, we eliminate the fraction or not, we're going to sort of get big numbers. So what I'm going to do is I'm going to multiply the first equation by 12. The reason being, there is no common factor between 3 and 4 other than 1. Here, I can multiply both of them by 24, because you can cancel 24 by 6, you can cancel 24 by 8. So both of them can be cancelled, so the denominators can be gotten rid of. So I'm going to multiply the first equation by 12 on both sides. So 12 times 2 over 3x minus 12 times 3 over 4y equals minus 12. Likewise, 24 times negative 1 over 6x plus 24 times 3 over 8y would be equal to 24. 3 and 12 would get cancelled 4 times. 4 and 12 would get cancelled 3 times. 6 would cancel 24 4 times, and 8 and 3. So we got rid of the denominator successfully. So we will have 8x minus 9y equals negative 12, negative 4x plus 9y equals 24. I'm going to get rid of y because one has a positive, the other has a negative. So if I add them, it's going to go away. 8x minus 4x is 2x. Bad math there. 8x minus 4x is 4x. Negative 12 plus 24 is positive 12. Divide by 4 on both sides. x would be equal to 12 over 4, which would mean x is 3. So we can take 3 and plug it in one of the two equations. Oftentimes, a mistake that's commonly made is that folks would take that x is equal to 3 and plug it in the original equation. Don't do that. We have to plug it in the simplified one. So I'm going to pick either this equation or that equation. I'm going to go for the second one. So -4 times 3 is -12, plus 9y would be equal to 24. Add 12 on both sides. 9y would be equal to 24 plus 12. 9y would be equal to 36. Divide by 9 on both sides. Y is 36 over 9. Therefore, y has to be